In this video, we will learn about what are the basic operations that can be performed on signals. So there are 6 different operations that can be performed on signals. They are time shifting, time scaling, time reversal, addition, multiplication, and amplitude scaling. So let us look at each of these operations individually so that we can understand them in detail. The first one is time shifting. So as the name suggests, time shifting means we are shifting the given signal in time. We are shifting the given signal in time. So let us see an example for it. So this is the original signal x of t. So x of t is defined from -1 to 3 and its amplitude is 2. So mathematically we can write as x of t is equal to 2 for values -1 less than or equal to t less than or equal to 3, right? So mathematically this graph can be written as this equation mathematically. Now shifting in time, so we need to shift this signal in time. So the value of t here is no longer t, it is x of t minus 1 or x of t plus 1. So to find x of t minus 1, how do we find x of t minus from x of t? So wherever there is t in the given mathematical representation, we'll replace it with t minus 1. So x1 of t is the name given to the new time shifted version of x of t. So this is nothing but x of t minus 1. So I will replace whatever is there, wherever t is there in this original representation with t minus 1. And then we'll simplify this inequality. So minus 1, I will take this minus 1 to other sides. Minus 1 less than t less than or equal to t less than or equal to 3 plus 1. Simplifying it, we get 0. This becomes 0 and this becomes 4. So our new signal must start from 0 and end at 4. The amplitude is 2. Amplitude is 2. Right? So this is the shifted version of x of t. So there is a minus sign here. There's a minus sign here which shifted the original signal to the right side. So a minus sign indicates right shift. A minus sign indicates right shift. So let us take a plus sign here. Let us consider a plus sign. We need to find x of t plus 1. So what we'll do, we'll replace t with t plus 1. T with t plus 1. So what happens if I replace t with t plus 1? So this becomes minus 1 and this becomes 3 minus 1, right? I take plus 1 to this side and plus 1 to this side. It becomes minus 1 and minus 1. So minus 1 becomes minus 2 and 3 minus 1 becomes 2. So how will my signal look? My signal will look like this, from minus 2 to plus 2, right? 2 and minus 2. From minus 2 to plus 2, the amplitude is 2, and all other cases it is 0. So when we have a plus sign, what does it indicate? This signal here, which starts from minus 1, is now starting at minus 2. So it indicates a left shift. Left shift. A minus sign indicates right shift, plus sign indicates left shift. Right shift means the original signal is delayed. Right shift also means the original signal, which starts at minus 1, is now delayed and it is starting at 0. So right shift indicates delay of the original signal. Left shift indicates advancement of the original signal. Similarly, the same procedure we'll use for finding the shifted versions of discrete signal also. So here in the discrete signal, we can see g of n can be defined as mathematically n plus 2 from minus 1 to 8. For values of n from minus 1 to 8, the value of g of n is whatever the value of n plus 2. For 9, it is 5. For n is equal to 9, it is 5. And for all other values, it is 0. For all other values, it is 0. So to find g of n plus 3, what we should do? We should replace n with n plus 3. So there's n here, there's n here, there's n here. So we'll just replace it with n plus 3. Right? So now we'll simplify. N plus 3 plus 2 becomes n plus 5. And this plus 3 I'll get to this side. And this one here. So what will happen? N plus 5. And this one becomes plus 3. When it comes this side, it becomes minus 3. 1 minus 3 and 8 minus 3. And this 3 when it comes here, it becomes 9 minus 3. So simplifying further, it is n plus 5 from minus 4 to 8 minus 3 is 5. So from minus 4 to 5, the value of g of n plus 3 is n plus 5. For n is equal to 6, the value is 5. Otherwise, it is 0. The same thing, we will represent it in graphical form. Right? From minus 4 to 5, the value of g of n plus 3 is n plus 5. Minus 4 plus 5 is 1. Minus 3 plus 5 is 2. Minus 2 plus 5 is 3, and so on. 5 plus 5 is 10. So at 5, the value is 10. At 0, the value is 3, 2, 1, and so on, right? So 0, the value is 5, 4, 3, 2, 1, right? And at 6, the value is 5, and at all other values is 0. So if you look at it, it is just the shifted version of g of n. G of n is starting at minus 1. G of n plus 3 is starting at minus 4. The plus sign indicates left shift. So the entire signal is shifted towards left side. It's shifted towards left side. So this is called advancement of the original signal. If there is a minus here, the entire signal will be shifted towards the right side, and it is called delay of the original signal. A signal x of t may be shifted in time, that is, it may be advanced or delayed. Based on the sign here, it can be advanced or delayed on time axis. If there is a negative sign, it is denoted by x of t minus capital T. Capital T can be any number. That is, x of t original signal is delayed by t number of units, and x of t starts t seconds later, right? It starts t seconds later. And similarly for advancement, x of t plus t, x of t is advanced in time by t units, and it starts t seconds earlier. It starts t seconds earlier. So look at this. G of n, we have g of n plus 3. So t is equal to, or t is equal to 3. So it is advanced in time by 3 units. That means it starts 3 seconds later. Here g of n starts at minus 1. So 3 seconds earlier means minus 1 minus 3. That is minus 4. So 0, minus 1, minus 2, minus 3, and minus 4. It starts at minus 4. So that is time shifting. Now let's move on to the next operation, time scaling. So we have to find the scaled versions of the given signal. Y of t is given. It is defined as the amplitude is 2 from t0 to 3. Right? Amplitude is 2 from t0 to 3. Now we have to find y of 3t. Time scaling, the common form is y of at. Y is just the variable name. It can be x, it can be z, anything. In place of t, we have at. For time shifting, we had y of, in place of t, we had t plus or minus capital T or capital A, whatever it is, right? We have t plus or minus thing. Here in time scaling, we have t multiplied with a constant A. So first we have to find w of t is equal to y of 3t. So to find w of 3 is equal to y of 3t, we replace wherever there is t here, we replace it with 3t. So 3t in place of t here, I am replacing it with 3t. Now we'll simplify this inequality. So I'll divide this by 3, divide this by 3, and divide this by 3. I'll get 0 less than or equal to t less than or equal to 1 as my range, and the amplitude stays 2. So graphically, how will this look? This one from 0 to 3, it is 2. Now w of t will become 2 only in the range of 0 to 1. Otherwise, in all other ranges, it is 0. In all other ranges, it is 0. Only in between 0 and 1, it is 2. So if you look at it, the original signal is now compressed in time. The original signal is now compressed in time. Now we'll find the next v of t. Sorry, this must be v of t. So v of t is equal to y of t divided by 3. So wherever there is t in the original signal, we'll replace it by t divided by 3. And now let us simplify this inequality. So I'll multiply by 3 for this whole thing. It becomes 0 less than or equal to t less than or equal to 9. Graphically, it becomes like this. It looks like this. So when you compare the original signal with this signal, what can you say? The original signal is expanded. Original signal is expanded, right? So in the general form y of at, the value of a decides whether the original signal will be compressed or expanded. If the value of a is greater than the value of a is greater than 1, if it is greater than 1, the original signal is compressed. If it is less than 1, the original signal is expanded. It is as simple as that. If x of t is the signal, x of at is the time scaled version of the signal. For a less than 1, there is compression of the original signal. Sorry, I think it's a mistake. For a less than 1, there is expansion of the original signal. For a greater than 1, there is compression of the original signal. So this is greater than, sorry, and this is less than. Less than means there will be expansion. The next one is time reversal. So again, let us take the original signal x of t. We already know how it is defined. It is defined as 2, 4, minus 1, less than t, less than 3. Now, time reversal means I have to reverse the sign of this time. Here it is plus, so I'll make it minus. So, to find x of minus t, what should I do? I should replace t with minus t. Now I'll simplify this one. It becomes 1 greater than or equal to t greater than or equal to minus 3. That means minus 3 less than or equal to t less than or equal to 1. So what happens to the graphical version? It looks something like this. This is x of minus t. X of minus t. So basically whatever is on the right hand side, it will be folded onto the left hand side. Whatever is on the left hand side will be folded onto the right hand side. So far we know how to find the time shifted version x of t minus 1 or t minus capital T, the scaled version x of at, and reversal x of minus t. Individually we know how to find all these three. Now what happens if there's a combination? If you look at here, there is reversal, time is negative, so there is reversal, and some capital T is also present here. That is, some shifting is also present. So it is a combination of shifting as well as reversal. When there is a combination of shifting as well as reversal, how do we find? First, we need to perform shifting operation. We have x of t, the original signal. So first we will find x of t, how much it is shifted, plus 4, right? 4 has plus sign, so we will find x of t plus 4. So after finishing the shifting operation, then we'll move on to reversal operation. Then reversal operation. So x of minus t plus 4. X of minus t plus 4. Right? Then, so we have completed time shifting, time scaling, and time reversal. The next one will be addition. Addition of two different signals. So here, this operation involves addition of amplitude of two or more signals. How many signals we are adding? All the signals amplitude at each instant of time they are separately added. So this is my x1 of t. So how can I write the mathematical equation for this mathematical representation? If you look here, this is one point, this is the other mathematical representation, right? From -2 to -1, what is the equation? What will be the equation? So we can take the 2 points here, that is -2, -2, 0 and -1, 2. Using this 2 points, we know the 2-point formula for line, so we can find the equation for the line. What is the 2-point formula for line? Y minus y1 is equals to y2 minus y1 divided by x2 minus x1 into x minus x1, x minus x1. So what is y here? Y is on the y-axis, we have x1 of t. So x1 of t minus, what is y1? This is y1. This is x1 y1 and x2 y2. So y1 is 0 is equal to y2 is 2. 2 minus 0 is again 2 divided by x2 minus x1. x2 is -1, x1 is -2. So -1 minus of -2. So -1 plus 2. -1 plus 2 is 1 into x-axis we have, this is time, right? So time t minus again x1. What is x1? -2. Minus of -2 becomes +2. So x1 of t is equal to 2 into t plus 2, right? That's what we have, right? 2 into t plus 4 in this range, in -2 to -1. -2 to -1. So from -1 to 0, the value is 2. From 0 to 2, the value is 3, right? Simple. Then this is the other signal. This signal we have from -2 to -1. What do we have? Here we have -2 to -1. So I'm taking the same range. -2 to -1, the value of x2 of t is 2. And again from -1 to 0, the value of x2 of t is 2. And from 0 to 2, we have to find the equation again. So what is the point here? The point is x-axis is 0 and y-axis is 2 and 2, 0. 2, 0. So if you find the equation, line equation for these 2 points, we'll get t 2 minus t. 2 minus t. You can verify this. It will be 2 minus t. So addition operation means we need to perform. We have to add the two signals. So basically we'll add the mathematical representation of these two signals. So in this range, -2 to -1, see we have the same range here, right? -2 to -1 and -2 to -1. So we'll just add the amplitudes. So 2t plus 4 plus 2. It becomes 2t plus 6 in this range. And if in the range -1 to 0, it has x1 has 2 and x2 has 2. So add both, we get 4. and in the last range 0 to 2 we have 3 and we have 2 minus t. So if you add both, it becomes 5 minus t. So this is how it looks. So minus 2 to minus 1 when the value of my t is minus 2. So 2 into minus 2 is minus 4. Minus 4 plus 6 is 2. At minus 2 the value is 2. Similarly at minus 1 t into 2 into minus 1 is minus 2 plus 6. 6 minus 2 is 4. So at 1 the value is 4. So we'll just join these 2 points. At 0, what happens at 0? When t is 0, the value is 4. Right? Value is 4. Again, when t is equal to 1, and here when t is equal to 0 again, the value is 5 minus 0, 5. So it starts at 4 and ends at 5. At t is equal to 0, it starts at 4, ends at 5. And when t is equal to 1, 5 minus 1 is again 4. So at t is equal to 1, this is the point. And at t is equal to 2, 5 minus t is equal to 3. So we'll join all these points. So that's how we add two different signals. At each instant of time, we'll just keep adding the respective amplitudes. Simple, in a simpler way, here minus 2, here there is minus 2. So the value here is 0 and the value here is 2. You add both, we get 2. Minus 1 and minus 1. The value here at minus 1 is 2. The value here at minus 1 is 2. Add both, we get 4. At 0, there is 2 here and there is 2 here. So 4. And again there is 3 here at 0 only. There is 3 and here there is 2. So 5. So continuously you just have to add the respective amplitudes. Same way for subtraction. Here we are just adding. If there is subtraction, if there is minus symbol here, what we'll do? This minus this. You'll get the result. Subtraction is also kind of addition, just with a negative sign. Then this is subtraction. You can check this later. Multiplication. Multiplication, just as addition, we will multiply. At each instant of time, we'll multiply the amplitude, right? So this is another signal. For this, we'll write the mathematical representation. This is the mathematical representation. For each period, minus 3 to minus 2, minus 2 to minus 1, I have taken the line equations and written them here. Similarly, for the other signal also, I have written, right? I have written the same. The first signal starts from minus 3 and ends at plus 3. So minus 3 to plus 3. The second signal starts from minus 5 to plus 5. I'm writing them individually. Just so I can the multiplication will be straightforward. So I can look at the range and then just multiply the corresponding amplitudes. You can write it however you want. You can just write from minus 3 to minus 1. You can just combine these two and write the amplitude is 1. You can write however you want. For simplicity purpose, I'm splitting the ranges. So when you multiply these two, we have a range minus 5 to minus 4 here, and here that range is not there. In that range the signal is 0. So there is no common thing. So 0 into 1 will become 0 for all values less than minus 3. See, the signal is 0 for t less than minus 3. So whatever is there less than minus 3 here, it becomes 0. Any value multiplied with 0 will become 0. And then from minus 3 to 2, we have 1 here and we have t plus 3 here. So it becomes t plus 3. So -2 to -1, we have 1 and 1. 1 into 1 is 1. 1 to plus 1, sorry, -1 to +1, we have 2 and we have 2. So 2 into 2 is 4. 1 to 2, we have 1 and we have 1. So again it is 1. 2 to 3, we have 1 and we have 3 minus t. So multiply, we get 3 minus t. And here greater than 3, all values are 0. So whatever value is there here greater than 3, we can make it 0. So this is how the final multiplied signal will look like, right? Then amplitude scaling. Amplitude scaling is very simple, very similar to multiplication. Very similar to multiplication. We are just multiplying the amplitude. So let us say this is my original signal. This is a sinusoidal signal, right? The amplitude is 1 and -1. It goes to the positive side 1 and -1. Now, if my alpha I am multiplying it with a multiplicative factor. This is the scaling factor alpha. If it is less than 1, if it is less than 1, I am reducing the size. That means I am reducing the size. If it is greater than 1, I am increasing the size. Less than 1, I am reducing the size. That means the signal is attenuated. If it is greater than 1, I am increasing the size. That means it is amplified. So mathematically, I am calling it as y of t is equal to alpha into x of t. Alpha, I am multiplying this thing to the amplitude. So it is amplitude scaling. Previously, we have seen time scaling. We have seen time scaling. It looked like this, x of at. So basically, I'm multiplying this a, the constant, with the time axis. So it is time scaling. Now I'm multiplying this alpha to the amplitude, right? Amplitude outside the entire function. So that is, I'm multiplying it with the amplitude. So amplitude scaling. So take down, and you can practice all these 6 operations on these 2 signals. You can find this is the scaling version, scaling, time scaling basically, and this is addition, and this is shifting, and this is scaling plus shifting operation. You can find out these things